Firstly, I'd just like to acknowledge the AMCA, massive effort that you guys have put into in establishing the BIM-MEP-AUS standards for the region in such a short period of time. I think to be congratulated, there's no doubt. It's a concept that we obviously buy into and support all the way. As Mark said in his opening address, there's a lot of confusion around BIM. What's it delivering now? What's possible in the future? What we're going to talk about today is what we're delivering right now on many Australian construction sites. Okay, so it's not vaporware, it's solutions and products that are taking the data out of your building information model in the office, and we're replicating that accuracy in the field with these tools. Warwick spoke about BIM all the way, and for SurePoint and Trimble, that means from the office to the construction site, with a focus on the construction site. That's what we're all about. What this means to plumbers, duct installers, foremen, the actual guys on the construction site. That's what we're all about with our products and our services. It leads me into the mindset that I had when I first started SurePoint about 12 months ago. It was simply this, that technology drives business only when it's implemented. It's SurePoint's mission to provide practical BIM tools and achievable solutions with a focus on the construction site. Okay, so we're taking a bit of a different approach right now from what you've heard this morning, I guess. There's a lot of talk about BIM in the office and onto the manufacturer model. What we're talking about is placing this information, this powerful information, in the hands of plumbers and duct installers, and we're doing that right now. This is the agenda that we'll be going over. Very quickly, the introduction, which I've just done. A Trimble overview. John Inman is the global BDM for the Trimble products that are in the BIM space, so he'll be taking over that part of it. We'll talk about and we'll answer the question, why use BIM on site? What's in it for the guys on site? We appreciate all the benefits in the office, but what's in it for the guys on site? For me, it's a lot about the cost of rework. Rework is a considerable burden on the industry. I've got some information here in the presentation about what rework actually costs the Australian construction industry. Now, when I give this presentation, that part of the discussion usually generates a lot of interest. Everyone's got their own view of what rework costs, and I've got some data here today that's Australian-based data. It's a survey of 161 construction projects in Australia, and it puts $1 as a percentage term of the contract value on what rework actually costs. We'll talk about the BIM-to-Site Solution as we see it and the services around that, and we'll also talk about how you go about laying out with an RTS. It's a robotic total station. It's the latest technology. We've got one out in the foyer if you'd care to come and join us afterwards. I'll hand over to Jim for the Trimble part of the presentation. Sorry, John.
Good afternoon. Again, my name's John Inman. Currently, I'm Business Development Manager for Trimble's Building Construction Division. I've held a lot of hats at Trimble. I've been with them for 21 to 25 years, depending on which acquisition you count. And I've played from being a software engineer, working in the dirt, from sales to product management to segment management, which is strategic planning for our product development. About 4 years ago, we got more and more involved in building construction. Trimble was heavily focused in the construction side in the heavy highway area and mining and that part of construction, and we were missing getting our technology to be used in vertical construction. And so we started looking at that about 4 years ago. How could we play a bigger role in that market and that type of construction and improve productivity there? So just to give you kind of a quick history about who Trimble is that we have a market focus today really where we're really known as on the construction, surveying, agriculture, mapping, and GIS markets. We're a leader in several positioning, control, alignment type technologies. This includes GPS positioning, robotic total stations, 3D machine control, lasers, and then what we call task-focused field software. What we've learned is that we've developed a lot of technology over the years, and in order to get technology used in the marketplace, it's not up to us to go out there and train people how to understand our technology. It's up to us to come up with user interfaces that work, that make our technology work the way the people in the field work. So we don't want them to have to learn. It's kind of like a DVD player or a VCR. You don't want understand how that technology works, you want to know how to use it to do your job. And that's really what we mean by task-focused field software. So we're trying to create UI that works the way the field workers think so that they can focus on doing their job more productively and with better quality. We are a publicly traded company, and I don't know what our number of employees now. We had a recent acquisition of Tekla, which added another 550 employees. So that puts us over the 4,000 employee mark. If you look at the middle picture, which shows a bulldozer that has two masts on it, and that's got two GPS receivers on it. And the reason I bring this up is in the Australian market, this was a technology that took a long time for it to finally get accepted. The Australian market tends to do this and hold back and really look at the technology, and then when they see it proven out, then it explodes in the market. And today I would say that Australia is probably the best penetrated market in the world for 3D machine control, where they're taking that technology and using it. And how that technology works is that we're taking 3D models, putting them into the control boxes inside of the bulldozers and motor graders, and using our positioning equipment to tell the machine where it is, what elevation it is, and then we automatically control the hydraulics and control the cutting edge of the blade. Now what we're trying to do is take that similar concept and be able to take a coordinated 3D model and information from that model, carry it out to the field so that you can actually replicate the design in the field physically to make the building match the design. So why use BIM on site? There's been a lot of talk about building information modeling, what it means, and the things that it can do for you. It absolutely helps improve clash detection and where you can find mistakes in the design before you actually get out in the field. Model-based cost estimation, construction planning, communication across all the stakeholders, and supply chain management. Huge benefits to all of these things and absolutely worth getting involved with the BIM process. But what happens when you get out into the field is that the paper plans come back out and it leaves this 3D model that's been coordinated back in the office. And traditional methods are then still being used for layout. You're pulling out, manually scaling distances off the plans, turning angles with theodolites, pulling tapes and strings to lay things out. Not actually using the value of this highly accurate 3D model that's been coordinated across all the different trades to do the layout and physically build the building. And this is critical because, as y'all all know, accuracy is required by all the trades. It doesn't matter if you're laying out footings, foundations, anchor bolts, if you're laying the interior walls, floor penetrations for your pipe sleeves, inserts for pipe and duct hangers. All of this requires accuracy because mistakes are costly, and it's not solely because of the rework. We know that rework's expensive, and we're going to talk more about that, but it also, mistakes affect multiple trades. It will delay the start of other tasks when you run into problems, and it delays crews from other groups downstream. It can require design changes due to the mistake. Sometimes you can't fix the mistake. You actually have to make a design change to get around the mistake and account for it. The picture on the right, that particular project, it was a nasty project. There wasn't a 90-degree angle in the building, and the plumbing contractor doing this, trying to lay this out manually with a 13-degree angle off of the outside wall and a 17-degree angle off of that wall to try to get a 3.5-inch pipe sleeve into a 4-inch wide wall. It's $800,000 in rework and fines on this one particular job, doing it manually. So it can be extremely costly. But we also have, and David's going to go through some studies that have been done in the Australian market about what the true cost of rework is.
Yeah. Thank you, John. So I put this together because more and more I find myself in front of general contractors giving this presentation. One of them in particular, Lend-Lease, asked me to put a number on rework. They had their view. They asked me, what was my view, so I went and did some research. Plenty of information on the internet, there's no doubt. What I found though, and was most topical to Australia, was an Australian-based study by a fellow by the name of Professor Peter Love out of the University of WA. What he did was he went around to 161 Australian construction projects, had his team of people go around to these projects and question them. What does rework cost? I should say that the research that I found put that number anywhere between 3% and 23% of the contract value. Now, you know, it's a fairly wide range, obviously. A lot of that was overseas information. But what they found in this Australian-based study was that the average direct cost of rework was 6.4% of the contract value, the direct cost to that subcontractor, to that plumber who put that penetration in the wrong place and had to recore the slab, to that duct installer who had to pull down his hangers and reinstall it. 6.4% of the contract value. The flow-on effects, or the indirect costs of that rework, was an additional 5.6%, so a total of 12%. Now, I bet you everyone in this room's got an idea or think they've got an idea of what rework costs them, and whether it's 5% or 12% or 20%, I think we can all agree it's a significant number and a burden to the industry. It's interesting to note that the consequences, obviously, reduced profit, loss of reputation, increased work turnover and possible litigation. I mean, there are obviously a whole bunch of nasties that no one wants to experience. The factors that led to that rework, design error, straight up front. 30% of that number is design error. And obviously what the BIM-MEP-Oz forum is trying to achieve and is achieving rapidly is going to detail and get rid of a lot of this 30% of design error. But nearly half of that rework came from construction execution error, simple setting out errors, putting the wrong penetration in place, not being supervised adequately, low skill levels. Half of that number, so it's a significant amount. The rest of it was due to incompatible materials, damage by other trades or weather, so things out of our control. So my point throughout all of this is that for 3/4 of that rework number, whatever it is something that we can address with the use of building a constructible model in the office and then laying that out digitally in the field. We'll get rid of a big part of that number. In my view, this problem will only increase. Subbies are asked to lay out more and more complex structures and services, often in 3D. And on the flip side of that, the surveyor on site is asked to provide less and less control on the site. So typically a surveyor in his contract, it's been ratcheted right down, he'll be asked to pin a grid line every 10 metres with a very small nail head and a couple of RLs around the walls. Quite often he can't hit that grid line because it's on a line of columns, so he'll offset it and put a bit of mark with spray paint. By the time the subbies get to the deck, there's pallets in place, there's a load of duct in place, they've got very little control to go from. So quite often they're using a couple of control marks, very small nail heads, and it's really quite a difficult task. We're all about putting the paper plans away. One of the case studies I'll talk about is a Triple M project, one of the first to adopt this technology in Brisbane. I remember very clearly giving the presentation to a group of about 12 in their Brisbane office, and I think 2 guys straight away loved it. They were right on board, they could see the benefits. 2 guys were the exact opposite, hated it, thought it was the biggest load of bull they've ever seen, and people were generally in the middle. Obviously the guy that took, they went on and bought the kit, the fellow that they nominated as their technology champion, a young fellow who very much took ownership of the kit. On the first floor that he laid out, not only did he go out and install 540 hanging bracket points in one day, 540 points, but he also drew the lines of duct in, the bends, the T-pieces, marked the VAV boxes. So he very much replicated the paper plan onto the underside of the slab. And I clearly remember the guy, one of the naysayers who was one of the 2 that couldn't buy into it, walking onto that deck and looking up, and there was his paper plan. He had his paper plan in his hand, and there it was replicated on the underneath of the slab. It took him about a week of measuring to his paper plan and then measuring up to the deck before he was satisfied that what we were laying out was accurate. So I'm very happy to say that he too is now a converted fellow to the layout. So we're all about, as much as possible, putting the paper plans away. With John's spoken about this, taking the accurate model data to the field in terms of a field controller. Again, we've got one out there that you're welcome to come and have a look at, and laying it out on site with an RTS, a robotic total station. That's really only one part of the circle, if you like, though. What we're doing when we're out in the field is we're capturing the as-built information. If that plumbing penetration can't go on the design because it's on the top of a ridge on a piece of bond deck and it's got to be moved over 100 mil, we're recording the as-built of that penetration. And in the layout report that we encourage the users to give back to the office on a weekly basis, they'll have the XYZ coordinates of the design and the XYZ coordinates of the actual and the delta, the difference, so that that movement of that penetration can be uploaded into your as-built. It's dynamically keeping track of your as-built. Might hand over to John here to detail the Trimble part of the kit.
Yeah, so I really just want to kind of go through just the components of what makes up the layout solution. I mean, first, you're going to have what we call a field controller or a tablet. So this is going to be a tablet. We have also the handheld field controller, depending on which terms ends up being just the best form factor for the person in the field and which specific functionality that's needed. Then you have the robotic total station. Now this is a robotic total station, makes it a one-person solution. And so there's communications either via radio, a 2.4 gigahertz radio, or a wireless network. And that information is going to communicate with the field controller so that you can control the instrument. So if you lose lock on the target, you can control it with the joystick, bring it back to you, search and do that. So you don't ever have to walk back to the instrument to re-hook up to it. You can do that remotely from the field. And the telescope on the optics on the total station, which one's the laser pointer?
This one go forward?
No, I want the laser pointer. Oh, that's going to go forward. That's what I was afraid of. Can't read this without my glasses. You fix that. Thank you. So I'll just. So the optics are going to track the prism and follow you wherever you go. So as the person walks around with the rod and the controller in his hand, it's going to track wherever he goes on the site and tell him where he is. So what it does is it's going to allow you to set up that instrument anywhere on the site. So you can set the instrument anywhere you want to be so that you have the best visibility to the site. Then you can shoot to 2, 3, 4, up to 5 known points on the site in order to tell the instrument where it's located on the site. And it's going to show you where you are now. So where the red arrow is pointing, you've got a little crosshair. That indicates where you're standing on the site with your rod. Then as you walk around, it's going to move and show you your position on the site. Then it's telling you what your current location is, your desired location is. So it's pointing to where you want to go. And it's also giving you the directions on how to get there. So as I'm facing the instrument and I'm looking at it, it's always giving me directions as I'm looking at the instrument. So if the instrument's over there and I'm standing here, it's going to tell me I need to go back from the instrument and to my right. If the instrument's on that side, it's going to tell me I need to go back from the instrument and to my right to get to that point. So it's always giving me directions in relationship to where the instrument is and to where I'm standing. So it's very easy to navigate to where I'm trying to go. And then when I get close to the point, it's going to shift into a bullseye view that lets me know that I'm within a meter, and then I'm just bringing the circles on top of each other to get to the desired location. Now, I can set a tolerance in the software that tells me, do I want to be accurate to within 10 mil? Do I want to be accurate to within 5 mil? What's the level of accuracy? And when I go to stake that point, if I'm outside of that tolerance, it's going to flag me, tell me I'm outside of the tolerance and by how much. If there's a reason to accept that, you can, but it's going to flag it red, so you know that you took a point that was out of tolerance. If you're within tolerance, it's going to stake it, flag it as green, so you know that you were within tolerance and you move on. So you got a very quick check to know whether what you did in tolerance, what was out of tolerance. Of course, if you're out of tolerance, it allows you to go back and reshoot and take the shot again. And one thing that's really important, this is, I'll admit, it's not an inexpensive instrument, but I don't worry about it. It's construction tough, and that is a working unit. So it will survive drops on concrete, still work, although I actually changed the color, so I'll go back to the black background. And if that one is mine, so I didn't do it to Jim's, I did it to my own. I'm not worried about it. Jim's going to take you through what we call the BIM-to-Site cycle.
Okay, Jim, off you go.
Jim, just,
what is the name? Okay, so the BIM-to-Site cycle all starts with BIM or CAD in the office. I guess you guys know about all that. The services have to be detailed and coordinated, an extremely important step. It's got to be a constructible model, and that's what you're here to all talk about. Whether that's a CAD Duct model, whether it's a Tekla model, AutoCAD MEP, whatever it is, it's got to be brought in at this point and made into a constructible model. I will make the point though that here, at this point here, that's not the as-built, okay? That's just the as-designed model. It's not the as-built until we actually get out into the field and construct it. So we export it to the site, we digitally lay it out with a total station, keeping track of any movements, any alterations in the field, if any penetrations have to move over, walls, whatever. We're keeping track of that information, we're populating the as-built on a weekly basis. It can be quality checked and then loaded back into the model. So that's what we mean by the BIM-to-Site cycle. I've spoken a little bit about this already, so I won't go over too much about it again. We do, as Jim stated earlier, we do extract the point data directly from the model. We can do that within CAD Duct. We can do that within Revit and other tools. So we're taking the information directly from the 3D model and laying it out in the field. The on-site solution from my point of view is to supply total station layout kits to all subs, along with layout training. Okay, so again, I'm in front of a lot of head contractors giving this presentation, encouraging them to adopt digital layout technology. They're very open to it. If they've made the step to BIM, they're very open to then utilising digital layout solutions to replicate that accuracy and then populate the model. The layout kits and workflows are so easy to use that a surveyor is only necessary for training, supervision and quality checking purposes. Any subby can do it. We've got many examples in Australia right now. This is the Gold Coast Hospital site. It's a large site. There's about 10 or 11 tower cranes on that site, and there are roughly 1,000 penetrations per floor on that job. Okay? This guy's a plumber. He's not a surveyor. But what he's doing is he's laying out the penetrations prior to concrete. And you can see what he's done in the foreground of that picture there. He's marked the point with an X. He's got some attribute data there, so the person coming behind him knows that that's a 90mm stormwater pipe or a 150mm sewer pipe or whatever it is. And then he moves on to the next position. Mark Hayes is the project manager for Beavis on that site. What he says is that the Trimble picks up other trades anomalies, partition walls, formworkers, etc., which enables us to adjust if required. So when they're laying out, they get to that point for their penetration. If for whatever reason it doesn't line up with the formworkers or the interior walls, they make that change then and there, okay, before concrete. That's the point. This leads to very little rework. We work in with the surveyors on site who give us grid intersections and off we go. He's proud of his team of plumbers who have been keen to adopt the technology. The Trimble has led to near zero rework. This was one of the first companies, along with Triple M, to adopt this technology. What this did was made the technology very visible to Lend-Lease. Lend-Lease now, as they move forward, particularly in Queensland, want to roll this out onto their next lot of upcoming projects. So I'm working closely with them in Queensland to get this sort of technology going. I mentioned this site earlier. It is the Triple M site. It's 111 Eagle Street, a Leighton's job. This is the fellow here that he shoots 540 points per day. They only use the instrument 1 day per week over a 54-floor building. You will find a case study about this site in your bag, your welcome bag. It details the savings that Triple M achieved on this site. I can tell you though, in a nutshell, in 3 days they laid out and installed the hangers on this site per floor. In 3 days, each floor, laid out and installed the hangers. A saving of 6 days per floor over 54 floors. Thank you, Mark, for allowing me to say that. It's been a great site for us. Peter Zack is the project manager, site manager on that site. He says, the mechanical system on this project is complex. We must locate 540 points per floor to direct the installation of ducts, hangers and pipes, and we must do it quickly to minimise contractor traffic on each floor. So they're there. As soon as those props are stripped, they're onto that deck and they're laying out their points to get in there before the other trades do. The MEP kit creates perfection. 100% install per design, since every point's accurately located on site, negates clashes with other services. So, the steps to achieve accurate layout to minimise that rework. It starts with a clash detected and coordinated model. Very important, you guys as the mechanical contractors, more and more, you're being asked to also be the coordinating contractor. A huge task in my view, and one that carries a lot of risk also in my view. So it's very important to get this right. We're encouraging head contractors to specify that the surveyors not only put a nail every 10 metres, but they also put a highly visible network of public control points around the walls. Okay, so that it's there for everyone to see. It's not going to get materials placed over the top of these control points. They're going to be a lot more long-lasting and a lot more meaningful to the trades. Specify. A lot of the head contractors now are going to specify the use of total stations to their subs. This will allow quality checking of the layout reports. The goal obviously is to supply the as-built model with actual installation information, an intelligent model for the clients for handover and facilities management purposes. That's where we want to get to. That's what BIM-at-BOS is all about. I don't expect you to read this. This is an example of the specs that I've been working with several head contractors on to put into the contracts. Doesn't say SurePoint, doesn't say Trimble. It just says use a digital layout solution in the field. Might hand over to John, yeah?
So, layout's done several different ways using the robotic total station. First, and probably in different parts of the world, it depends on which ones used the most and depends on what's available to the contractor as to what they can do. So we talk about laying out points on top of the deck from above. And it's fantastic when the contractor can get on top of the deck, ahead of the concrete pour, get all their points, their floor penetrations, their hanger inserts laid out on top of the deck, and get off the deck before the concrete pour. The reason it was never done this way typically was because you could never stay ahead of the concrete pour, which controls the construction schedule. You do not alter the concrete pour, especially on a 24-hour, 7-day-a-week job. And so now, getting time windows for being able to do your layout fast enough and get things placed on top of the deck, you can get on and off the deck, do it accurately, and stay ahead of the pour. And that makes it a safer environment. You can do it more accurately. You don't have to come up and drilling up overhead, and it works extremely well. This is not happening everywhere. It's happening in the U.S. It's probably predominant in California region, Chicago area, not so much in the Northeast yet, but we're working on it. And then they're going to pull and actually put their threaded rods in and add the hangers into it. And so this is just an example of some inserts that are being used for the threaded rods. You know, there are different brands, but Hilti has several. Some people call them Stompits, some call them Bangits. And they basically bang into the steel deck or the wood decking before the pour, and there's a plastic insert that after the concrete's poured, you go in, unscrew the plastic insert, and you've got your threaded insert for the rod that you just screw into it. You can also lay out underneath the deck. So there's a laser pointer inside the instrument that we can turn on. And what that does is it shoots a laser dot to the ceiling and places a red dot on the site where you can mark the point. Now naturally, the deck is not going to be at exactly the correct elevation as the design. It's just not going to happen. It's going to be off 5 mil, 10 mil, even as much as 40 or 50 mil in some cases where it's dropped. What happens is the instrument knows where it is. It knows what elevation you want it to be. It shoots to that point where it should be by design, but it remeasures the height of the deck and says that deck's too low. That means I didn't get to the point that I was trying to get to. So it knows that. It readjusts the measurement based on the new height of the deck and adjusts it to put the point where that horizontal position needs to be. So it has that information in the model, in the design, so it's able to make that adjustment on the fly. The person in the field doesn't have to do it. We can do the same thing with wall layout. If you're trying to lay out a penetration through an existing wall, it'll go and turn and measure where the wall is. It knows the line that you're trying to get to penetrate the wall, and it'll iterate until it finds the intersection point of the designed penetration to the actual wall that exists on the site. and does that without the person in the field having to do any calculations to figure that out. It does all the math automatically for them and just puts the dot where they need to mark. So when they're laying out from below, of course, they get those in there, then they're doing the same thing, bringing the points up. So some of the benefits here. One, when you're using BIM-to-Site, ideally you want to use a synchronized clash-detected BIM, coordinated model across multiple trades. One of the messages we're trying to give to the main contractors or the head contractors is if you get your key trades, these main trades all using same control, models that have been clash-detected together, and all of them using this type of technology to do their layout, you're going to get a project that fits together a lot better out in the field. And you're going to minimize field problems. We have a PCL in the United States and Canada. They have a saying in their company as a general, and it seems backwards, but they go, we want to build it twice. And what they mean is they want to build the model of this construction site virtually as a 3D model with all the trades in it, and they want to have that replicated in the field exactly as we designed it. That's their goal. So build it once virtually and build it a second time physically exactly as designed. Trying to minimize rework. We know how much that costs. As we went through the numbers and the percentages, one of the reasons that range is so broad from 5.6% to 23, 30, actually even 40%, is because a lot of these studies are focusing on what's the rework cost to the main contractor, to the general contractor. It doesn't actually factor in the buffer that all the trades have built into their bids to account for the rework that they know they're going to have. Because you have to have that buffer because you're going to have that cost somewhere. So that's not even factored into those numbers, which is why you see the numbers range from single points to 40, and I think one particular contractor claims it's 50% on their project. So it is a exceptionally expensive problem. Linking the office to the job site. So you're trying to communicate. The tools have the ability where you can email data back and forth from the job site back to the office. If you're a remote site, you get the hotspots, and you can take layout data and as-built data that's been collected back and forth to the office with saving drive time. You don't have to drive the data back and forth and improve that communication. As I just said about the layout across the different subs, trying to get a successful project is trying to get everything done on time and under budget. And an intelligent as-built 3D model, getting that back out allows you to give a better product that you're turning over to your customer when you're done. It gives you a more accurate record. You have to turn this over, and it actually improves the product in which you're delivering to your customer. And that, in result, gives you a much more satisfied customer, satisfied owner, which hopefully will generate repeat business for you, for that particular owner.